Hey guys, this is video 7.4, classifying reactions. All we're going to do here in this video is talk about the different types. There's 5 of them, and then kind of give you some tricks to identify the type of reaction. And then in 7.5, we will talk about how to predict products. So this is a pretty easy thing to do, being able to classify once you know what they look like. The best thing for you guys to do to help master that is to make flashcards. So 5 flashcards. If you don't have any, ask me. I can give you some. On one side you write the name, on the other side you write the general equation, and then maybe some examples that we're going to write down, and then just look over them over and over. It's very important that we can classify reactions because in video 7.5 we're going to be predicting products. So in that video you're going to be given reactants, and you have to write what the products are going to be based on what type of reaction it is. So let's dive in and kind of get going with it. So page 11. First thing we're going to start with is reaction number 1, and that's called a synthesis reaction. Another term you might see is called a composition reaction, where if you think about the word synthesis, synthesize, things come together, you're making something new. So in this reaction you have 2 or more substances combining to form one brand new substance. Okay, that's the key here, is that you have one new substance form in a synthesis reaction. So general equation, A plus X yields AX, where element plus an element, or substance plus substance, and you have one new substance. So it could be single elements combining together to form a binary compound, or it could be 2 different compounds forming together to make one new compound. So a couple examples, we have sodium chloride, sodium plus chlorine yields sodium chloride. Now the question I have for you is, why is chlorine written with a subscript 2 and sodium not written that way? So think about that. Hopefully you can answer this question right away. If you can't, guys, you need to go back and reread your notes, specifically video 7.2 on these types of elements. The answer to the question lies right here. Brinkelhoff, all right? Those are the 7 diatomic elements. When they are by themselves as elements and not combined in a compound, they exist in a diatomic state, so they have a 2 subscript. What I encourage every one of my students to do is to write this Brinkelhoff down on any test or quiz before you even write your name, just to help you remember, hey, if I see those by themselves, it's got to be a 2. So now we'd have to go through and balance this. All right, so we'd have be 2 there and a 2 there. So this example is where you have an element plus an element making a compound. Another example is where we could have 2 compounds. So we have calcium oxide plus water reacting together to form calcium hydroxide. Okay, where you have 2 compounds coming together, but again, the same thing still holds true. Both of these reactions, they only have one product, okay, one substance on the right side, and that's how you identify a synthesis reaction. Kind of on the flip side here is a decomposition reaction. So when you hear that term decomposition, what do you think of? For me, I think of Bambi on the side of the road, decomposing, breaking down, and that's exactly what's happening here. Sorry if that's not the best image, but it's usually one that drives home the point with my students because it's something they can remember, where you have a single, very complex substance breaking down or producing 2 or more simpler substances. So when something's decomposing, right, you've got this complex organism, and then it starts breaking down into its different pieces over time to produce something simpler, and then it's gone. So in this case, you see one piece on the left side, so one reactant, and then it forms multiple products. For me personally, this is my own opinion, decomposition is the easiest reaction type to identify because it's the only one where you only have one thing, one substance on the left side of the arrow. So some examples that we are going to write down here include potassium fluoride breaking down into potassium plus fluorine. Again, same thing. Oh, why is F2? You should know the answer to that by now. So if we have to balance this, what I would encourage you to do is pause it, balance it, and it would be balanced like this. Another example, calcium carbonate. This is something you're going to make later this year. It's going to break down into calcium oxide plus carbon dioxide. Okay, so again, compound, but it breaks down into 2 compounds this time. Still a decomposition reaction because you only had one more complex substance on the left and you have multiple pieces on the right. So whether it's a binary compound breaking down into its single elements, or a complex compound breaking down into multiple compounds, same thing. Another example, sodium hydrogen carbonate breaking down into sodium oxide plus water plus carbon dioxide. I want you to pause the video, go through, and balance this equation right now. To balance it, it would be 2 sodium hydrogen carbonates and then 2 carbon dioxides. Every single one of these is the same. They may look different. One may look more complex than the other guys, but notice they all start with one reactant and then they form multiple pieces over there on the right. Now there's a special case or special type of decomposition reaction called electrolysis. All right, I wish I could show you this in person. There's videos out there on YouTube. I'll put one in the playlist for this unit. But all it is water breaking down into its individual elements through the use of electricity. So electrolysis, if you break that term down, guys, it's electricity. So electricity is the catalyst, and this is a term, a symbol that you guys should be familiar with if you look back in video 7.1 in your notes that go along with it. All those different terms and symbols that you need to be aware of. So if you ever see that electron symbol, or sometimes it'll be just like a squiggle on top, meaning electricity, same thing. Electricity was the catalyst that broke that down. Again, decomposition, one substance becoming multiple substances. Kind of the flip side of synthesis, where synthesis you have multiple things becoming one. Now we'll get into the replacement types of reactions. So this is the first one is a single replacement. Sometimes you'll see it called displacement, means the same thing. So single replacement or single displacement mean the same thing. This is where you have one element, so an element by itself, replacing a similar element in the compound. The thing you want to remember here, guys, is like replaces likes, or like, excuse me. Okay. Kind of like back when we did polarity, likes dissolve likes, like replaces like here. So what we mean by that is metals are going to replace metals, nonmetals will replace nonmetals. Okay, so maybe you want to jot that down. So metals replace metals, nonmetals replace nonmetals. And we'll get into a lot of reactions here and practice with it. A hint that might make it a little bit easier for you guys is you see water in the reaction, writing it as HOH might help and make it easier to balance. You'll see what I mean here in a minute. So our first example we're going to write down, we've got aluminum plus lead 2 nitrate, okay, is going to produce lead by itself plus aluminum nitrate. Now there is this thing that governs single replacement reactions, guys, called the activity series. We will talk about that in the next video when we start predicting products, and we'll spend more time later on in the year when we do redox discussing the activity series as well. It's actually table J in your reference table. Go through, balance that equation, make sure that it is balanced, right? You got to get that practice in, so pause the video and go and do it. When you balance it, you should have 2 moles of aluminum plus 3 moles of lead 2 nitrate yields 3 moles of lead plus 2 moles of aluminum nitrate. All right, next example, sodium plus water. What I would encourage you guys to do is write it like this. Sodium plus HOH yields sodium hydroxide plus water. And the reason I encourage students to write water this way is now you can see the polyatomic ion on both sides. So you can balance that as a package deal instead of trying to split it up just hydrogen oxygen by itself. It's up to you. You can leave it as H2O. It may make your life easier though to do it as HOH and then balance the polyatomics as a package deal. Again, that's up to you. All right. In this case, to balance it, you would need a 2 here, a 2 here, and a 2 there. Now, both of these examples that we've done so far, guys, are metals replacing metals. Let's get you an example where you're going to have a non-metal replacing a non-metal. Specifically, those non-metals you're going to see are the halogens. So something like chlorine plus potassium bromide will produce potassium chloride plus bromine. Okay? And notice it's bromine 2 and chlorine 2 because of those diatomics. When we balance it, it should look like this. So, single replacement reaction, and one single element is going to replace another element in a compound to produce a new compound and a new element. One thing I want to point out, guys, with the diatomics, this is an element right here. This is an element. Those diatomics, just because you see a subscript, does not mean that they are a compound. That is a single element. Brinkelhoff means still that it's a single element. It's just so reactive that they want to bond with each other to be stable. All right, type 4 is going to be a double replacement. Again, same thing, you'll see it as double displacement, where you have excuse me, the ions of two compounds switch places to form two brand new compounds. We have a whole unit where we're going to be dealing with solutions later on, and we do these things called net ionic equations. We'll be doing a lot of double replacement reactions within that. A lot of times when you have a double replacement reaction, one of the new compounds is going to be a precipitate. If you do not know or remember what that term means, go right now, look it up, and write the definition right here. You have to know what precipitate means. All right, so know what it means. Super important. Examples, we're going to have potassium iodide plus lead nitrate, lead 2 nitrate. Notice how I'm putting symbols in here as well. All right, lead iodide, lead 2 iodide. Oh, look, if you don't know what that symbol is, go back and look at your notes. You've got to know what certain symbols are, guys, within reactions. You could see them at any given time. And then aqueous over here as well. All right. And I was going to make you balance it, but then I got writing and I forgot to do that. Next example, guys, silver nitrate. Aqueous as well, plus sodium bromide. It's going to yield silver bromide. Now look, there's that arrow again. You got to make sure you know what it is. Plus sodium nitrate. That is a 3, my apologies. And the last example, a reaction you guys will do later on, we do acids and bases. Hydrochloric acid plus sodium hydroxide. It's going to yield sodium chloride plus water. And again, writing it as HOH can make it a little bit easier to balance. All right, and the last type is everybody's favorite reaction, is called a combustion reaction. This is what you guys probably thought you were signing up for when you were dealing with, or when you signed up for chemistry, was dealing with explosions. Everybody loves these because they're the poster child for chemistry, but most of chemistry is not like this. Most of chemistry deals with solutions, which is double replacement. But anyway, combustion, guys, when a substance combines with oxygen, releasing a large amount of energy, often in the form of light and heat. So combustion reactions, guys, involve this thing called a hydrocarbon. Don't analyze this or overthink it. Hydro, hydrogen. Carbon, carbon. So it's a compound, guys, that has carbon and hydrogen in it. We'll talk more about hydrocarbons when we do our last unit of the year, which is organic. But for now, to identify a combustion reaction, look for oxygen as a reactant and then the same two products every single time. They will always produce water and carbon dioxide. So when you're around a campfire, carbon dioxide and water are being formed all the time. You don't see the water because it's in the form of vapor or gas because it's so hot, but it's still being produced there. So the one example we're going to write down, C3H8 plus O2 yields CO2 and water. I want you guys to go through and balance that, and then also you're going to go through these 4 reactions down here. You're going to identify the type, you're going to write them, so like number 2, yeah, you got to go from the words to the formulas, and then make sure you balance the equations as well. This example, to balance it, hopefully you've paused it, 5 oxygens, 3 carbon dioxides, and 4 waters. Until next time, have fun classifying reactions.